For centuries, when we looked through a telescope at Saturn, we saw a picture of absolute serenity. The rings appeared as perfectly still, silent ribbons of ice, decorating the planet like ancient monuments frozen in time. That stillness was a trick of distance. When NASA sent the Cassini spacecraft to study Saturn up close, its instruments revealed a violently active environment. The rings are a chaotic storm of collisions, constantly shifting and surprisingly young. We find the true mechanism behind this dynamic ring system by looking past the giant planet itself. The real architects are the hidden moons orbiting right inside the debris. It turns out, every giant planet in our solar system has a ring system of its own, but they don't all look like Saturn. This diagram compares the ring structures of the outer planets. Jupiter, Uranus, and Neptune are circled by faint, narrow ribbons, made mostly of dark dust and rock, so dim they are nearly invisible. Saturn's rings are massive by comparison, and they shine brilliantly because they are made of 99% pure water ice. But a giant disk of loose ice and dust presents a physics problem. Left to its own devices, floating debris will gradually drift apart and dissipate into the vacuum of space. Something powerful has to intervene to keep all those billions of particles organized. A ring system starts at the Roche limit, a boundary where a planet's gravity overpowers an orbiting body's internal gravity. If an icy moon crosses that line, tidal forces splinter it into debris. Inside this limit, intense gravity also prevents loose dust from clumping into solid moons. Either way, the brilliant bands of ice we see today are essentially the ghosts of moons, either shattered long ago or permanently trapped in pieces by the planet's gravitational grip. While the planet's gravity creates the raw material, it is the surviving moons that sculpt it. They do this through a process called gravitational resonance, where the orbital path of a moon repeatedly aligns with the orbit of the ring particles. Take Saturn's Cassini division, a massive gap 4,500 kilometers wide. Moon Mimas orbits outside it. Every time Mimas completes a lap, its gravity gives the ice particles in that specific region a tiny rhythmic pull. Over millions of years, that repeated tugging completely clears the lane. Those broad gaps are carved from the outside in. But looking at the rings of Uranus, or Saturn's outermost edge, the F-ring, you don't see massive fields of ice. You see incredibly tight, narrow ribbons of dust and rock. These extremely thin bands only survive because they are escorted by shepherd moons. These are pairs of tiny moons, like Prometheus and Pandora, orbiting along the inner and outer edges of the ribbon. Their gravity acts like a fence, bumping stray particles back into a sharply defined line. Without these hidden architects sweeping the debris, the intricate chart structures would collapse into featureless clouds. This textbook scan shows a tiny moon of Saturn named Enceladus. Notice the inset in the bottom left. Those are geysers of water and ice. These eruptions at the South Pole actively breathe a new ring into existence. To find out exactly what this moon was venting into space, scientists programmed the Cassini spacecraft to fly straight through the erupting plumes. The sensors detected a rich chemical mixture. The geysers were spraying liquid salt water, laced with ammonia, methane, and complex organic compounds like hydrogen cyanide. This chemical signature reveals a massive, warm, liquid ocean hiding beneath the freezing, cratered crust. Because Enceladus is so small, its gravity cannot hold on to this erupting water. The ocean spray escapes into space, spreading out along the moon's orbit and constantly replenishing Saturn's massive, diffuse E-ring, single-handedly preventing it from fading away. The rings are dynamic environments, driven by the active geology of their moons. In the case of Enceladus, the icy ring is a direct sample of its subsurface ocean, carrying the building blocks of life into the vacuum where we can actually reach them.